Thank you all. Hi, everybody. I'm Eric. I'm here to talk to you about your containers. And if you're running them as defaults with the default settings in your orchestrator or even just in the runtime engine, why you are a hacker's best friend. Um, don't have really a lot of time here to talk about myself, so just know that I'm a software developer. I am a senior developer advocate at Snyk, and I have a bunch of credentials in whatever you can read. If you want, you can follow me on the Twitters and everything else at Eric Smalling. But let's get into what I have left for the 15-ish minutes I've got. And yes, we have little time. So first, we're going to talk a little bit about containers and what's new for developers as they move into containers. We're going to show you an application that might be vulnerable because of some things you didn't know about. Then I'm going to hack that application because it is vulnerable. Then we're going to get into how you can prevent that and finally wrap up. So the challenges we face. So as a developer coming into containers, one of the first things that really will hit you when it comes to security is that, we already were aware of we have to keep our code clean and our libraries clean and all that kind of good stuff. But as you add Docker or whatever container system you're using, as you're building these images, you're having to take on operating system level concerns and network level concerns and all sorts of things that increase the scope of what you're doing. Where is that base image coming from? What's in it? What Linux distros in it? What file permissions and user permissions and all sorts of stuff, package management, all that things that we're aware of. We've done any work on Linux. You're aware of all these things. However, and to be honest, we kind of threw it over the wall in the past. It was like, oh yeah, the sysops and the security teams and the storage teams and whoever else will handle this for me, and they'll tell me what I need to use, and I'll just make sure that my software runs on those platforms. Well, now those things are right in our court because the Docker file, the Kubernetes YAML, and all these things are infrastructure as code. They are saying they are codifying things that if hopefully you're working with those teams to form them up. But if I go in there and I make a change to make something work or to fit an enhancement I'm doing, did I just make it less secure? I don't know. I hope not. We really don't have a deep level of expertise in hardening systems for security. We may know how to harden our applications, but when it comes to, hey, that app repository get you just did in your Docker file, did you do it in a secure way? Did you leave things laying around on your file system that you shouldn't? I don't know. You have to know how to do that. And on top of all of this, we're in a continuous delivery, DevOps, agile, iterative kind of a world, and velocity is to business, velocity is king. And adding these security tasks to a developer's day-to-day work can't make it slow down that velocity. In fact, they probably just want to continue to ratchet it up and get things out to market faster. Enough about these slides. Let's get into my demonstration and get to it. So set the scene a little bit. Let's say you're at a company. We have a Java application, JEE application that has been around for a long time. It's in kind of a maintenance mode. We're not really doing much other than a few tweaks here and there to it. We were running it out, on servers in production for years. And a couple years ago, we lifted and shifted it into a container and are running it on Kubernetes to take advantage of the ease of the standardized deployment packaging and all the stuff that an orchestrator gives you. And here's the Docker file we're using. And you can see if you've looked at Docker files before, this is a multi-stage Docker file. You can tell because it has 2 from lines, and you can have multiple froms in that kind of a Docker file. The last one is the one that goes, builds the final image and gets shipped. You see, we're building using Maven, and I'm not downloading half the internet. But the second, gosh, I threw myself off. The second phase, we are starting from an official Tomcat image at hella old 8.5.21 version. Why? Because that's the version that was working in production when we containerized this thing. And if it ain't broke, don't fix it. Stasis good is, the kind of the attitude a lot of people have on older apps. Well, we're setting a couple configurations on that, copying in some artifacts from the build stage and getting going. And if we go look at my Tomcat server, I'm running this locally in Kubernetes on my Docker desktop. This could be any Kubernetes cluster or any Docker thing. So we can see here, there's our sample servlet showing us that. We can see the app running. It's a beautiful app. And why would you want to change that? Let's leave it alone, right? Well, let's pick our hat. How put the black hat on as a hacker. I'm probably looking around for vulnerable applications, and if I may specialize in Tomcat and Java. And this is the Apache official page of fixes for vulnerabilities and all the things they've patched through the many years. And if you look through here, there's all sorts of stuff. There's denial of service attacks. There are information disclosure vulnerabilities, all sorts of things. If we scroll down to I believe, I skipped it. There we go. There is a remote code execution vulnerability that was fixed in 8.5.23. That tells me that anyone that's running anything older than that might be vulnerable. Now, I could go into this CVE, and this is our vulnerability database, kind of like MITRE, that shows that kind of information. I can dig into this and figure out exactly what is the problem with this Tomcat util library, right? Well, fortunately for me, there's a couple exploit DB links, and one of them has a Python script that is a proof of concept, and I can test out my server and see if it's vulnerable with it. So I've aliased that. Let's take a look at it. So I've got this alias called check. It hits my local IP, and you can imagine this would be running in some kind of war dialer style loop, looking at all the servers that might have Apache on it and tickling it with this. And sure enough, I am vulnerable, and it has dropped a POC JSP onto my server. And when I say dropped, I mean injected the JSP into a remote Tomcat server. And those A's, those aren't very nefarious. But the fact that I pushed JSP onto that server, yeah, that's pretty bad. So what else can you do? Well, it has a second function in there that if I run called tone, and we'll change this to PWN. Now I get this little form. That's the environmental variables in my Tomcat environment. I just ran a command in a shell alongside Tomcat. And I can look at this and I can say, I see Kubernetes, so we're probably running in a container. If I wanted to, if I had time, I don't have time with you guys today, but I could go after this. This is the control plane, the API server for the Kubernetes cluster I'm running in right now. And I could look at things like, let's take a look at what's mounted on this. Sure enough, I have this, and I could go in here. Let's just do an ls on it. There's my token. That is the default. If you don't turn this off, the default, the service account for the pod that's running, in this case, it's default for this one, but automatically puts a token in there for it to be able to talk to the Kube API. So if I could get kubectl, if it's not on here already, I could get that. I could start talking. I start messing around, seeing what I have available to me. Let's see, do I have curl on here? I do. So I probably could go start pulling things around. And again, I've got limited time, so I'm going to go past a lot of this. But the other one I will run, though, is, and I'm root in the container. That's always fun because I can do cool things like, let's see. And now let's take a look at Etsy. I just created a file in the Etsy file system. Inside the container, I am contained, but I am UID 0 in this container. So I can do all sorts of things. If I had more time, I'd show you that I could do apt-get installs. I could put, if nmap's not in here already, I could install it for myself because this happens to have access to the Debian app repos or some company's app repos if it was running in their systems. I'm in, and I can start making a beachhead and growing my exploit. Now, to be honest, at this point, most hackers, most bots, or whatever that are going to try this attack are probably now curling a script down to do crypto mining on your node and take over all the CPU it can, and denial of service any other pod that's running on that node. So how could we have prevented this? Well, first thing, actually, I'll show you on the command line. First thing would be to make sure that you're not introducing these things from the get-go. So I'm going to run our tool. Now, there's many container scanning tools out there. I'm just going to use ours because I'm kind of partial to it. I'm going to do Snyk container test, and I've already built this locally. Imagine I'm back at the company now. I'm the developer working on this app. I'm going to give it a little metadata by feeding it the Docker file that built this. And get this so I can talk and not wait. So what this is doing now, any good container scanner is going to be ripping through all the layers of the image and looking at all the things that are installed in those layers. It's then also, in this case, I'm feeding it the Docker file, so it knows specifically what tag this came from for a base image. Doesn't have to guess at it from hash or anything. And it knows each one of those layers. It kind of get more information, as detailed information about what it is you did. And as I scroll back through the results, there's a big list of vulnerabilities coming up here. In fact, like all these curl things showing that if I went to a newer version of curl, I could get past these. So I could go through that and figure out and fix everything. But even more interesting is at the bottom where we see, it says, hey, you're based on this really old version of Tomcat. It's funny, every time I run this, it changes because the different vulnerability database, changes. It's saying if you move to a much newer version of that same minor Tomcat, you can reduce that number greatly. If you're willing to upgrade, you could go to even less. Or if you're willing to go into an alternative like the Corretto JVM, you could go to 0. Now, at this point, even as a junior developer who knows nothing about Tomcat and its internals, I could go to my architects, my leads, my AppSec folks, and look at this together around my desk and say, hey, what should I do here? And like, oh, we're not ready to go to Tomcat 9 because we'll break under that. And I'm not ready to drink the Kool-Aid of, a brand new JVM. So let's just go ahead and upgrade to a newer Tomcat version that gets us down less, and we can look into mitigating these unfixed issues that it has. Now, that's great for known vulnerabilities. But what happens, my slide went forward. What happens if you have 0 days or other things? How can you better prepare your runtime environment for unknown exploits? Well, there's 3 areas, and my slides aren't working. There he is, to remind me to keep going. 3 areas I want to talk about. First of all, images. So we touched on the fact that I used a multi-stage build, and that allows me to whittle down that final image to just what I need to run my application. Minimizing the size of your image isn't just about performance and being able to transmit that around a lot. It's about not giving hackers tools to attack you with. And the fact that curl was in there, the fact that apt-get was in there, is a side effect of the fact that I used the full-on Tomcat image. There are slim versions of the image that don't include those things. There are also other things like the distroless packages or images from Google that don't even have a shell. They don't even have a package manager. You can try those if they work for you, great. But minimize those images. Don't give the hackers tools that they can start, expand their exploit. Learn about Docker, how they build layers, how the images are built. I don't have time to get into that here, but understand that. Use multi-stage or other build strategies to make sure you are making small, good images and have repeatable builds so that every time you pull a commit, you build the same thing. That means use specific versions of tags. Don't just use like 8 or 8.5 because that's a moving target. It'll always be moving to the next build one. And secure supply chain, you could have entire conferences about this. In fact, they do. But the gist of it being, know where your images come from, know how they got built. Nothing that Eric Smalling built on his laptop should ever get deployed to a server in my company because you don't really know what's in that. You have an audit trail if it was built by your automation systems. Next, this is the meat of this. Don't run as root in the at runtime. The fact that I was UID 0 gave me extended privileges or elevated privileges in the file system of that container. And I could do things that I wouldn't have been able to do if I would have just used a non-privileged user. For instance, the Tomcat image, I believe, has a nobody user that I could be using instead. Node.js has a node user that I could be using instead. Do that. It will serve you well. Privileged containers I didn't talk about, but that's basically giving you root on the host. Never run in privileged mode. The only applications that ever need this really are like low-level monitoring tools and network interface plugins and things that business apps were just not doing. So just don't even use it. Linux capabilities, if you don't know what those are, go look it up. It's basically system calls you can make from your process. The container engines will narrow down what capabilities are available to a process, but for business apps and most enterprise apps, you probably don't need any of them. So deny them all, see if your app will run. There are tons of blogs out there you can look at on how to determine if your app's not working and what capabilities you do need through strace and Puffco and things like that. Make your file system immutable. If you can at all do this, this is like a great one because then I can't curl scripts down. I can't change your JVM, swap it out for a hacked one. I can't mess with your app. I can't change anything on the file system. It's going to make it harder for me to use that as a beachhead for extended exploits. As I said earlier, deploy from known sources. If you are on Kubernetes, there are some tools that you should be using. For instance, secrets. Legacy apps, a lot of the time we had like property files that ops would go in and add the database credentials to, in the dark on their SSH terminal after deployment. Don't do that. Use secrets. Don't bake a credential into your image, for Lord's sake. Don't do that. Use secrets. Make sure that if you're rolling your own Kubernetes clusters, that you're encrypting those secrets at rest, because that's not on by default. Most managed clusters it's on, but use role-based access control to manage who gets access to those secrets. Use RBAC. Use role-based access control. It's a great tool. Security contexts are the specs on the pod and containers in Kubernetes that implement a lot of the things you saw on the prior slide. So that link, I will send these slides out. Watch my Twitter feed. I'll post these. But that link will take you to a cheat sheet that my colleague Matt and I wrote to talk about all the, a bunch of the security contexts and hit on the things you need to know about them. Network policy is your friend. Make sure you are using it. As a developer, you look at it first, it's like, oh, this is kind of crazy. That firewalls, I don't know how this works. It's not that complicated. It's just all about what pods can and can't talk to each other on what protocols and ports. That's all it is. Just learn it, love it. It's a great tool. And then finally, all the things I'm talking about, enforce them at deployment time. Tools like OPA, Gatekeeper, Kyverno. There's also pod security policies, although that is deprecated and being replaced by pod security admission, which is in beta in the next release. So if you're using PSPs already, great, but be prepared to switch. Anyway, all of that to be said, I made it to the end, and I think I actually have a couple minutes remaining. If there are any questions coming up, I'll try to figure out how to get to them.
No worries, no worries. We can help you with that, Eric. I love the animated GIFs in your presentation. Like TikTok time. First of all, I want to congratulate you, because I know that you recently became a Docker captain. So congratulations on that one.
Thank you.
If you have questions or that are in any way Docker related, feel free. I would go to Eric nowadays, because so I don't have to Google or Stack Overflow it myself. Besides that, one question well, what I'm struggling with, what you see in many teams is when they create a Docker file, that they're not specifically using one base image, but using the latest.
Yeah.
I would say that in this case, with the Tomcat hack that you showed, having the latest Tomcat version in would have solved it automatically. So is that a good practice or not?
Yes, that's it's an interesting topic I've had over many beers with people. The latest is a great tool to use on your desktop. As a developer, while you're working iteratively on something, it's great. But the problem with it at production is it does give the latest, tagged version. However, you don't know what it is at the time of build. Every time you do a build, it should be a deterministic practice. It would be kind of like in Maven if you were to use release as a release. I forget, it's been a while since I've done some Maven work, but the tags in Docker images are mutable, and latest is just like 8.5. It's always going to be the latest 8.5, which is okay. But every time you do a Docker build, every time that CI process runs, if you're not specifying an exact version, you don't know what you're going to get. And it's better to pin to a version, but have a scanner like Snyk or anyone's that will tell you if newer versions are available with less vulnerabilities and react to that. So move the pin, but have it pinned is my advice.
Okay, so for on your local machine, it's okay to use, but once you go to production, make sure that you pinned it so it's a deterministic process and you can recreate whatever you did specifically. And
yeah, and you can get fancy with build args and have it be a variable and pass it in. Your CI server has like a set, and this is the Tomcat version our company uses. And there are other tools. In fact, there's a build tool called Jib that's great for this, where you can specify your configurations corporately and pull them in through Maven dependencies and stuff. And that's if you're a Java shop, Jib's a great build tool.
All right, we'll look into that. Thank you, Eric, for this this great talk and the actionable demo, and it scared me a bit, to be fair. So thank you for that, and I would say, I hope you enjoy the rest of your long day, because it's early for you.
You can caffeinate some more.
Yeah, absolutely. Got them too. See you around. Thank you.
Bye-bye.